So we've seen three forms of a straight line, and this is just a summary, a recap of all the other things that we've learned. So here's a straight line, one that I've used before in these videos. And one way to look at this is to say it has the equation 2x plus y equals 6. All right, we know it's linear because the x and the y are to the first power. That's what makes it linear. And I'm going to put the form of this equation in yellow below. That's ax plus by equals c. That's one form we've looked at. Now this same equation can be modified. We can solve for y, right? We did that. And we could say this equation y equals minus 2x plus 6 also describes this line. And this had the form y equals mx plus b. That was the second form that we looked at. And we can look at this and say, all right, well, the slope is minus 2. Minus, that should mean that as we move from left to right on the graph, we would be going downhill, and in fact we are, so minus makes sense. We can also take a look at this slope and say, is it negative 2? If I start here on the line and go down 1, go down 2, that would be the rise as a minus 2, then I would run a positive 1. So yeah, looks like minus 2 is the slope. And then 6 is the y-intercept. We have 1, 2, 3, 4, 5, 6. It does in fact go through the y-axis at 6. So that makes good sense. And then the third equation, or form of this line, is something like y plus 2 is equal to minus 2 x minus 4. Now this particular form, we pick an arbitrary point on the line and it goes into this form: y minus y sub 1 is equal to m, which is again that slope of minus 2, that makes sense, times x minus x sub 1. So the point that we picked would be minus 2, 4. So if I go over to, I'm sorry, the point that we picked would be 4 minus 2. If I go to 4 here in the x, right, this should correspond to minus 2, if I can do this, over here in the y-axis, and it appears that that makes sense. Alright, so three forms of this line. Now we can go from one form to another somewhat easily. Certainly we can go from form 1 to form 2 just by solving for y. We can actually go from form 3 to form 2 also by solving for y and then simplifying. It's hard to go from 2 to 3. Alright, I wouldn't even really attempt it at this point. It's not too bad to go from 2 to 1, but it's not particularly easy. Normally we start with 1 or 3 and move to 2. And we do that, we're going to go to from, let me do it this way, we're going to go from 1, that form, or form 3, and we're going to go from these two to form 2. And the way we're going to do that is we're going to solve for y and then simplify. Alright, so let's do an example. Okay, so I'll start with the example I had. This was the form 3. We had a name for this form. Do you remember what it is? point-slope form, right? And we're going to go to slope-intercept form, or form 2. So I'm going to do this by solving for y. Well, solving for y in this particular case is fairly simple. I'm just going to subtract 2 from both sides, and I get y on the left is equal to minus 2 times x plus 4 minus 2. And now I'm going to simplify. So we say, all right, I'll distribute this minus 2. So I get minus 2x minus 8. I'm sorry, did I make a mistake? No. Minus 2. This should have been a minus 4. I did make a mistake. I'm terribly sorry. The original problem had this being a minus 4. So that would make this a plus 8. There we go. And when I combine like terms, I get minus 2x plus 6. Good. So had I written the problem down correctly in the first place, we would have seen very smoothly that this actually comes out to be the same equation, y equals minus 2x plus 6, which we had before in form 2, or the slope-intercept. And we started up here with the point-slope form. Let's try another one, a different problem. We'll just make something up. We'll say y plus 7 is equal to 3x minus 2. So let's think about this. What's the slope? That's right, 3. And the point that we're using, remember the point is always x comma y. The form was x minus x1, so x1 must be 2. And y1, it was y minus, so I'd have to have a minus 7, and that's the point. All right, but let's redo this. Let's put this in terms of the slope-intercept form. So I'm going to solve for y by subtracting 7 from both sides. Simplify by distributing the 3, and then combining like terms. So here it is. So I should have, if I were to plot this, I should have a y-intercept of negative 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I should come through at about there. We know a point on this graph is at 2, negative 7. 1, 2, 3, 4, 5, 6, negative 7 is about here. So I know there's a point here. Do I know the x-intercept? Not so easy in this form, is it? But I know the slope is 3. Right, so if I start at this point, which was 2 minus 7, with a slope of 3 over 1, that's a positive slope, so I'm going to want to go, this could also be minus 3 over minus 1, right? That's also 3. So I could go down 3, 1, 2, 3, and to the left 1. Remember I'm at 2 here. And then 1, 2, 3 to the left. And in fact, we'll come through right where we thought we would. Alright, so this is another way of kind of making sense of our lines. All right, 3 different ways. Let's look at one more. This is that first form, ax plus by equals c. C in this case is 0. And one way to get to slope-intercept form in this case, if I have this form to start with, is to, again, solve for y. So I'm going to add 3x to both sides. What does that give me? Well, these go away, right? And I'm left with minus 2y is equal to 3x. Then I'm going to solve for y, continue to solve for y. In this case, I'm going to divide by minus 2 on both sides. So I get 3x divided by minus 2. Now remember, this is the same thing as 3 over negative 2 times x. So this is the equation for the line. What is the y-intercept? Well, what's the slope? This is in the form y equals mx plus b. So m is 3 over minus 2, or minus 3, that's a strange 3, or minus 3 over plus 2. Sometimes it's easier to leave them in this way if you're dealing with rise over run, but we could also say it was a negative 3 over 2. Right, all those are the same number. And b, b, what is that? Well, what have I actually added to 3 over negative 2x? Nothing. Yeah, that's right. Absolutely nothing. So b is 0. So this particular line is going to go right through the origin. So let's draw this line. I'll draw it in pink. So we know it goes through the origin. That's the y-intercept. And my slope is 3 over minus 2. So I can start at the origin and go up 3. 1, 2, 3. That'll be the rise. And negative 2 over to the left, negative 2, and put my next point. All right, I could have also used the next form of the slope and said, well, I'll go from the origin minus 3 in the y direction and plus 2 in the x direction, and would have had a point over here. But I think you can see, if I can draw this, that both those points are in fact on the line. Great. So now we have 3 ways of expressing a line, and we can draw the graph from any of those. And that concludes Math 60.